Hello everyone, welcome to CodeTube channel. In this tutorial, we will learn about vector database. So we all know about traditional databases. You have always heard different traditional databases, like you know about SQL, SQL Server, MySQL, Oracle. So these are all the traditional databases which we have used. Okay. So the traditional database are mostly which stores the data in a structured format. Okay. The data is generally stored in a table format. So we have rows and we have columns. Okay. So this is how the data is stored in the traditional databases. Now, for example, if we have data which is unstructured, let's say that we have a paragraph or we have PDFs or we have lots and lots of text files. So how we can store that kind of data which are not in a structured format? So that data now we can store in vector database. Okay. So one of the feature of vector database is you can store unstructured data in the vector database. You can also store structured data as well. So this vector database helps you to store large data sets. Now how the data is stored? Now let's take one case. Let's take one case where we have an article related to photosynthesis. Okay, so we have article related to photosynthesis and it is very long. It is like 10-12 pages. So what happens, like this data is taken, then it is chunked and the embeddings are computed and that embeddings are stored in the vector database. Now what is embedding? Embedding is now why it is called as vector database? Vector database means the vector is computed and then it is stored. Now, and the vector is basically a array. It's a number. So vector is a mathematical number. So your data is taken, then it is converted into a vector. Vector means a mathematical number and then it is stored in the database. So that's why this is called as vector database, where your input data is stored along with the mathematical number in the database. Then you can RAG your data and get the results. Okay, so we will study the RAG concept as well, but this is the basic understanding. So what happens in the vector database? You take a data, you calculate number, means this data is converted to a number which is known as vector and then it is stored in the database. So this is what the vector database is. So if you look at a definition, a vector database is a special kind of database that really good at storing and working with collection of numbers. These numbers could represent things like location on the map, characteristics of object or features in images. So your data is converted into a mathematical number and then it is stored, and that mathematical number which represents your data. So for example, if I search word photosynthesis, then it will check. First of all, I need to convert this photosynthesis word into embedding and then I need to search in the database and then it will retrieve me results related to photosynthesis. Okay, so this is the vector database which helps you to store unstructured as well as structured data. Now why we need vector database? We have SQL, we have lots of traditional databases, right? So what is the need of vector database? So first need is similarity search or spatial queries. So for example, if you want to get the nearest neighbor, let's say you have a word, let's take any company name. Okay, so ABC, there is a company name ABC. Okay, and if you want to get all the related data regarding that company ABC, then you can easily get by doing the similarity searches. Okay, so you don't need to provide the exact name of the company. Even if you provide you know any name of company which is a nearby ABC, then it can get you the results. So that can help you for similarity search. The next thing is efficiency. The data is stored in a, you can store large amount of data very efficiently, and the indexing is also very fast on this data. You don't need to explicitly do the indexing and all. So that is the one of the feature. And also scalable, like you can scale up, like large amount of data you can store, and also the time of query is very less compared to structured databases. In structured databases, what happens, you write a query like, for example, select star from table name. So this query takes lots of time. So here that query time is also reduced. So that is the efficiency. Indexing is also very fast. You can get you can do similarity searches based on, like, you can write a natural language any natural language sentence, and based on that you get the relevant documents from the database. So that is one of the benefit. Then scaling, then you can do it for large databases. It is easily scalable. And then making them better suited for tasks like finding similarity item in large data set, analyzing spatial relationship, or performing complex mathematical operation on vector. Okay, so these are all the features of vector databases which are not available in traditional databases. Now, I have explained here how the vector is computed, and like how the searching is done in vector database. Let's say we have a data which is related to book. Okay, so I want to store all the information related to book in a vector database, and it has got genre, then author, plot, themes, and readers, etc., etc. Okay, so this is the data I have stored in the vector database, and this is my data. I have represented this data in a form of a table, but the data is not stored in the form of a table in the vector database. Okay, just to understand, I have written like this. So I have book 1, book 2, book 3. Okay, and book 1 is related to science and the author is ABC. Book 2 is related to science and author is ABC. Book 3 is related to arts and it is author XYZ. Okay, so if I just provide if I just provide the author name ABC, it will give me result book 1 and book 2. Even if the author name here is BBC, let's say if the author name is BBC, but depending on this it will take, depending on the information, like based on the similarity search, it will give me these two vectors as a result. If I asked vector database, like give me nodes related to ABC, okay, so it will give me result book 1 and book 2, because the vector, like the mathematical number for these two entities will be similar, because the topic is science and author is also ABC. Even if the author is not ABC for both the cases, still it will give me the result like this, like the nearest result will be book 1, second nearest result will be book 2, and then book 3. Okay, so this is how the vectors are computed, and then the vector search is done. Now here is also one more use case which we all use on a daily basis. So we all use music apps, right? We have Spotify, then we have lots of, also we have also we use Netflix. Netflix is not a music app, but it is also film. We watch films on that platform. So all these big platforms now do the personalized recommendation. Okay, so they do the personalized recommendation. So what they do, like for example, if you have heard songs, you have heard romantic song of actor ABC, okay, and if this film is released in the year 2000, okay, so take any song which is of actor ABC and released in 2000. If you have heard that song on your that particular app, then it will throw you similar recommendation. So similar romantic songs of actor of film ABC in year 2000, that is one recommendation. Another recommendation is similar romantic song in year 2000. So you will get different types of recommendation based on what you have watched. So this is possible because of vector search, similarity search. So this kind of task can also be done with the help of vector databases. So you can do the recommendations, film recommendations, music recommendation, product recommendation, as well as like on the website, such as shopping website, we have Flipkart, we have Amazon. So when you purchase a item, you get similar recommendations, right? So that similarity search is done, can be done with the help of vector database. Okay, so that is one of the benefit. Here you don't have to do the exact matching. If you just write shirt, then you can get different types of similar items. So that thing is possible because of vector database. Then there are different types of vector databases. We have Viviate, Pinecone, Milvus, Chroma, etc., etc. So there are lots of vector databases available now, and these are all known as dedicated vector databases. Okay, so these are dedicated vector databases, so which you can install and use. Okay, so this is all about vector databases. So if you have any queries related to vector databases, please write in comment box, And please like, share and subscribe this channel, and I'll see you in the next video. Bye.